Hello again. In this video, I'm going to go over Objective 4 from Section R5, which is about factoring binomials. So there's a couple of special cases that we're going to look at here. The first case that we're going to look at is when you have a form of a squared minus b squared. That's called the difference of squares. And that can be factored into a plus b times a minus b. If you FOIL this out, a plus b times a minus b, you'll end up getting a squared minus b squared. And that's because the middle term cancels. So let's just look at this to verify it. The first would be a times a, that's a squared, and then the outer would be minus ab, but then the inner would be positive ab, and those cancel. So the middle term cancels. And then the last would be b times minus b, which is minus b squared. So what's going to happen in this section is we're going to start with the form a squared minus b squared, and then we're going to factor it back into the factored form, a plus b times a minus b. Now you should be aware of the fact that there isn't a special formula for factoring a squared plus b squared because it's not factorable. Okay, so I just want to look at a couple of examples where we use this difference of squares formula. So let's say you had p squared minus 100. First of all, the first thing you should always do when you factor is pull out the greatest common factor. But in this case, the only thing they have in common is a 1, so there's nothing to factor out. Okay, and then in this case, hopefully you recognize this as the difference of squares. Now to verify that it's the difference of squares, what you could do is you could take the square root of this first term, the square root of p squared, and that would give you p. Okay, and that's going to be our a. And then if you take the square root of the second term, the square root of 100, you get 10, and that's going to be our b. And so I'm going to write it that way. It's p squared minus 10 squared, where a is p and b is 10. Okay, so that clearly shows that it's the difference of squares. And then you can factor it just by saying a plus b times a minus b. All right, so a is p, so a plus b is 10. All right, that's a plus b, and then a minus b. And so that's how it factors. And if you want to check this, you could FOIL this out. The middle term is going to cancel out, and you'll just be left with p squared minus 100. Okay, and you can see that p times p is p squared. The outer is minus 10p, the inner is positive 10p, those cancel out, and then the last would be 10 times negative 10, which is negative 100. Okay, so let's look at b. Now again, the first step always when you are factoring is to pull out the greatest common factor. Okay, and so in this case, I believe these have a 2 in common. Okay, so let's pull a 2 out. Okay, so that'll leave you with 16y to the 4th minus, now 162 divided by 2 is 81. So that'll leave you with 81 here. Okay, so that's the first step, pull out the greatest common factor. Okay, and it turns out that this is actually the difference of squares, and so let's check that. So let's just take the square root of the first term, and that would give you the square root of 16 is 4, and the square root of y to the 4th is y squared. Okay, and so that's your a. And then the b is the square root of 81, which is just 9. Okay, so I'm going to write it that way first. So this is really a squared minus b squared, where a is this and b is this. And you can double check that just to make sure it works. 4y squared times 4y squared. That's 16, and then you would add exponents here, y to the 4th. And of course, 9 squared is 81. Okay, so that matches what we have here. Okay, so now that we've identified A and B, you would now factor it. Of course, you still have this 2 in front, but then this would factor into A minus B, A plus B first, A plus B. Right, this is A and this is B, so A plus B, and then A minus B. Okay, but we're not done factoring this. This doesn't factor because this is the sum of squares, but this is still the difference of squares. Okay, so now in this case, let's see what A is. Let's see, the square root of 4y squared would be 2y, and then the square root of 9 is equal to 3. Now remember, the sum of squares never factors, right? This is not factorable. But the difference of squares does. And so this is actually the difference of squares, right? 2y squared minus 3 squared. Okay? And so let's factor that. Okay, so this factors into a plus b. Okay, remember a is 2y and b is 3, so a plus b times a minus b. Okay, and you could also check this to see if it's correct by foiling this out. And when you FOIL this out, you'll end up with 4y squared minus 9. And then you would FOIL these out. And when you FOIL these out, you'll end up with 16y to the fourth minus 81. And then just distribute the 2 that sits in front, and it will go back to this. Okay, so you can always check your answer. Okay, so then the next thing we're going to look at is the special case when you have the sum of cubes and the difference of cubes. So if you have a cubed plus b cubed, that factors into a plus b times a squared minus a times b plus b squared. If you FOIL this out, well, FOIL is the wrong term, but if you were to multiply this out, you would get 6 different terms. You'd multiply this a by all 3 of these, and then the b by all 3 of these. And what would happen is all the terms would cancel except for the very first one and the very last one. And you would end up getting a cubed plus b cubed. Now the way we're going to use it here in this section is we're going to start with a cubed plus b cubed, and then we're going to factor the sum of cubes into this. We also have a special case when we have the difference of cubes. So a cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. And if you were to multiply this out, you would find that it's equal to a cubed minus b cubed. Again, because you'll end up with 6 terms when you multiply this out. 3 of them come from multiplying a by all 3 of these, and then the other 3 come from multiplying minus b by all 3 of those. 4 of the 6 terms cancel out, and you're left with the first term, which is a cubed, and you're left with the last term, which is minus b cubed. But again, we're not going to be using it this way. We're going to be using it where we start with a cubed minus b cubed, and we factor it into this. Okay, so that's known as the sum of cubes and the difference of cubes. Now, one way of remembering these different sign changes, I think you can see there's a pattern here, but one way of remembering the sign changes is these two are the same sign, then these are opposite signs, and then this last one is always positive. And let's see if it's true for this one as well. Same sign, opposite sign, always positive. And so you can remember that by remembering SOAP, S-O-A-P. Same sign, opposite sign, always positive. Same sign, opposite sign, this one's always positive. Okay, so that's a good way of remembering the signs. And you can see the pattern is the same. A, B, A squared, AB, B squared. It's just a matter of remembering the signs. Okay, so just remember SOAP to remember the signs. Okay, so let's look at a couple of examples where we use those formulas. Okay, so example 9, part A, we have x cubed plus 125, and we want to factor it. So the first step, again, is always to try to pull out the greatest common factor. In this case, 1 is the only common factor, so there's nothing to pull out. And then hopefully you recognize this as the sum of cubes. And that's because if you take the cube root of x cubed, you get x, and that's going to be our A. And the cube root of 125 happens to be 5, and that's going to be our B. And that's because 5 times 5 times 5 is 125. Okay, so I'm going to write it that way. This is x cubed plus 5 cubed. Okay, so it's the sum of cubes. And then we just have to plug everything into this formula to factor it. Okay, so A plus B, so x plus 5. And then A squared, which would be x squared, minus A times B, A times B, x times 5. Now, I'm going to change the order of this. We usually write the number in front of the variable. And remember, the order doesn't matter because it's multiplication. Okay, so I'm just going to write that as 5 times x. Okay, and then plus b squared, so 5 squared. Okay, and of course 5 squared is 25, so I'm just going to write it that way. Okay, and then you can check this by multiplying this out, and you'll find that it ends up going back to this. Okay, and of course the way you would do that is either distribute the x plus 5 to all three terms, or you distribute the x to all three terms, and then the 5 to all three terms. And what's going to happen is you'll get 6 terms, 4 of them will cancel out, only 2 of them will remain, and the 2 that remain are the first term and the last term. And the first term you can see is x cubed, and the last term would be 5 times 25, which is 125. Okay, so you could check that and see. Okay, so then part B, we have this, and we want to factor it. So the first thing to do is pull out the greatest common factor. But in this case, there's nothing in common except 1, so there's nothing to factor out. And then hopefully you recognize this as the difference of cubes. And let's just check that. The cube root of the first term, this is the cube root of 8 is 2, and the cube root of m to the 6th power is m squared. And that's because m squared times m squared times m squared is equal to m to the 6th power, because you add exponents here. Okay, now the cube root of the last term, the cube root of 27 is 3. And of course, the cube root of n cubed is just n. Okay, so this is going to be my A, and this is going to be my B. Okay, so I'm going to write it that way. It's the difference of cubes, okay, where A is 2m squared and B is 3n. Okay, and then we just use the formula to factor it. All right, so a minus b times a squared. So that's a, and then squared, plus a times b, a times b, plus b squared. So this is b, and then I'm squaring it. Okay? And so let's just clean this up, and we pretty much have it at that point. Okay, so when you square this, remember you can square each of these individually. So 2 squared would be 4. And then m squared squared, you would multiply exponents, and that would be m to the 4th. Okay, and then rearranging the order here, 2 times 3 is 6, and then you have m squared times n. And then again, you could square each of these individually. 3 squared is 9, and n squared is n squared. Okay, and so that's how this factors. Okay, and again, you can check this and make sure that it works by multiplying this out. So you would take this and multiply it by all 3 terms here, and multiply this one by all 3 terms here, and that would give you 6 terms. 4 of them would cancel out. You would be left with 2 of them, and the 2 that you're left with are the very first term and the very last term. And so let's just kind of check that. The very first term would be what you get when you multiply these together. And so you can see that's going to be 8 and then m to the 6th power because you add exponents. Okay, so that's what you have here. And then the other 4 terms would cancel out. Okay, and then you get to the last term, which won't cancel out. And the last term would be when you multiply this one by this one. And you can see you get negative 27 and then n cubed, right, because you add exponents. Okay, so we have 3 special cases that we need to look for when we're factoring binomials. Okay, remember binomials have 2 terms in it. Okay, so the 3 cases you need to look for from this section is the difference of squares, which is a binomial, right, 2 terms. The sum of cubes, which is binomial, right, 2 terms. And then the difference of cubes, which is also a binomial. Okay, so we have 3 special cases for factoring these binomials.